Okay, so it's an observation because there was no treatment imposed upon the participants. Yes? We understand that there's an observation experiment. An observation, the participants choose the treatment. In an experiment, the treatment is imposed upon the participants. You're going to take an anger scale test. Who in this room thinks that they could beat me in an anger scale test? Really? You think you can beat me in an anger scale test? So, very simple. So that's not really a compliment. You should say, you're not angry.
You're not angry.
Thank you. Still a little too late. So here's what you got. Do you have heart disease? Yes or no? Low, moderate, or high anger level. Meaning, if you're uptight and you get easily angered, it affects your health. Does it affect your health? Well, let's do a test. So we've got the two-way table. Ready? You got a random sample. I told you that. So here's the null. Now, this is how you want to write these nulls and alternates. Okay? You need a little practice on that when you have a chi-square test. So you can write, there's no association between the two, versus there is an association, or you could say they're independent of each other versus they're not independent. Listening? Because that's a chi-square test of independence. You should write it the first way, the association. Because that way you could write that whether it was homogeneity or independence. It's not complicated. Just write it the way it is in the top half of the screen between the rows and the columns. There's no association between the rows and the columns versus there is. So that's observed. For expected, we know how to do that. But the calculator does it for us. You don't even have to have a test. If you put the observed matrix in your calculator and you just run a test, it'll automatically build the expected matrix, even if that's all the answer you want. Okay? So everybody go there now. Go to your calculator. Ready? This is 2 by 3. We do not count the totals. You get a matrix edit A, and you put in a 2 by 3 matrix, and you put that data in there. And after you have it loaded, you go to stat, test, up arrow until you get the chi-square test, which is what? Let's see. See? Does that see for everybody? You got it. I mean, is yours C also? Right. So, ready? You run the test. Well, I'm getting ahead of myself because I just want to build the expected matrix. So once you run the test, you go second quit, second matrix, type 2, push enter. It'll paste the matrix on the home screen, yes? Now what? Well, if your decimals are running off the screen, you go to format, and just truncate the decimals. Like put it in 2 places so the display will fit on your home screen. Am I speaking English? If you don't understand what I'm saying, you gotta slow me down. So you should get this. You should get this matrix right down here. the PDF, or I'm sorry, on the PowerPoint, it's truncated to 2 places. But that should be your matrix B. Where did it come from? The calculator did it for you, but it multiplied. 69.73 comes from the product of 190 times 3110 divided by 8474. Row times the sum of the row times the sum of the column divided by the grand sum. But the calculator does it for you. "30-second timeout." Is everybody up to that? They have that in their matrix B. I want it on your screen right now. When I walk around the room, I want to see your matrix B on your home screen. Or not. It's downstairs in the other room. Matrix B. Is that it? Right there. Right there. Is that it? Still here. You put the same data. You want that stuff in there? You take over. You do that with the second matrix. That's right. You just need the test. Because that's what builds the matrix. Static test. Once you do that, second matrix. You have two. You ready? All right. The conditions. SRS, the sample size is less than 10% of the population. The expected counts are greater than 5. You can anticipate a question like this in May, where the observed count may be less than 5. But that's not the condition. It's not the data you're given. It's the matrix that you run on the calculator, matrix B. All of those have to be greater than 5. What if they're not greater than 5? You didn't meet the condition. You still keep going. You make a note, that condition not met, which means you couldn't generalize that beyond your sample. You still keep going. The test statistics, the same thing. Observed, take away expected, square them. divided by expected, add them up. That's your chi-square test statistic, which means nothing to you standing alone. You either need to compare it to the table on your formula sheet or the table in the back of the textbook, or you need to have the p-value, which you compare to the alpha level. But, like, I'm listening to children who are in AP Bio, they're not dealing with p-values. They're just comparing the test statistic to the cutoff. They're getting a table with the cutoff value. You can do that. It's not as technical as what we're doing. The p-value is more important, but it still tells you whether to reject or fail to reject. We did this before. Snowmobiles, and do you belong to the Sierra Club? Like, meaning these snowmobiles are, polluting the area, but the people who are, anti-pollution, they have them anyway. So you got this matrix. What is it? 3 by 2. 3 rows and 2 columns. Row comes first. The null, there's no association. The alternate, there is one. Alpha level 5%, which is the default. What are you going to do? You're going to write chi-square test. Just leave it like that. The conditions, SRS. Yep, we had an SRS. There's more than 1,526. There's more than 15,260 snowmobile operators. And all the expected counts will be greater than 5. That's going to come up. They're the expected counts. And you could say the lowest expected count's 59, and that's greater than 5. So what happens? We get a p-value, which is essentially 0. And they say, you got to be careful with this scientific notation here. It's 0.000. 10 to the negative 26. It's way lower than this. And you should report the degrees of freedom. Degrees of freedom, your calculator will spit it out, but it's rows take away 1 times columns take away 1. So we have a 3 by 2 matrix, so it's 2 times 1. The p-value is essentially 0. We reject the null. So take a moment and read that. Very similar. They're identical. So here's the distinction, but I'm not, again, you can read this. I'm not worried about that in the least. I'm not watching scary movies. You got a 2 by 2 matrix, boys and girls. The movie scares them or not. All right, how many degrees of freedom in that problem, Nick? Yes, 1 degree of freedom. You have 2 rows, take away 1 is 1, times 2 columns, take away 1 is 1. 1 times 1 is 1. It says assume the conditions are met. What happened? This is what you saw last week. We showed you this output on an FRQ on the delayed open. And what happens? They put the expected numbers, this is kind of awkward. They're putting the expected numbers underneath the observed, and then underneath that is the contribution to the chi-square test statistic. So you got a lot of clutter there, you got to be able to read. So 7, 29, 31, 50 is what you would have typed in. The second row is going to be the expected outcome. The third row of these numbers are going to add up to 4.028 because that gives you the contribution of each cell to the test statistic. No associations. The null is an association for the alternate. Right? And they tell you the largest one, your calculator does this for you too. It gives you that contributions list. 1.883 has the biggest effect on the 4.028. It's the largest contribution to that. Okay, so we get a 4.5% p-value. The probability of getting a test statistic as extreme, but we got a more extreme by chance alone. The null been shows 4.5%, except for some bizarre reason, just to keep you paying attention, they choose an alpha level of 1%. You didn't meet the 1%, so we're in the body, so we F2 up. Now in reality, you would always use 5% if it's something dumb as movies and being scared. A 1% p-value is for testing a vaccine, not for scary movies. So what's going to happen? You look at that and you say, oh, it's lower than 5%. Yeah, but you got to read the fine print. They said use an alpha level of 1% in the beginning of the problem. Fail to reject. And then back to where we start. Okay? So here is the difference between homogeneity and dependence. Again, don't sweat that. We got enough to deal with without people getting stressed out about a nuance like that. I want you to say test rate. Because what's happening? The AP test is graded this way. You either get an E, a P, or an I for each component of the question. E, you see our class sign. And this is the E for essentially correct. We've got dozens of pictures of people making this hand sign. Essentially correct, you can have a blemish. It's essentially correct. And if you didn't identify it to be a blemish, but you would get it essentially correct. P is partially correct, and I is incorrect. So it's graded in a very different format to calculus. Very much more generalized than calculus is very specific. Okay? So the no association or independent. There is an association, tilde means not independent, and that's where the expected value comes from. So we're going to go here. We're going to pause the video and send you to 3 questions. 41. 41. SRS, the lowest expected count is more than 16, and there's more time, more than 23,150 middle-aged fins. The nulls, there's no association between going to the sauna and having a cardiac event. The alternate is there is an association. Well, if we find an association, you better tell Pup, don't go to the sauna. So we put in the
observed matrix, we run the test, and then we get the expected matrix. You're not going to do it that order. This takes you there, takes you there. Degrees of freedom. We got 2 rows, 3 columns. There's 2 degrees of freedom. Our test statistic is a number a little more than 6. The p-value is less than 5%. There is evidence that it's not a good idea to go to the sauna every week. Reject the null. If we reject the null, what type of error could we possibly have made? Hello? 1 or 2. 1 or 2. We reject the null. Type 1 error. What are the consequences of making type 1 error? We drove down the attendance at the sauna. I don't really think that's a big deal. Suppose we made a type 2 error. We make a type 2 error if we fail to reject the null, the false null. Meaning what? Go ahead, puff up. Go ahead to the sauna. It's fine. But it was dangerous. In this case, a type 2 error is way riskier than a type 1 error. Does that make sense? Unless you own the sauna, probably. 43, SRS, lowest expected count's more than 42. This is backwards. The null and alternate are wrong. The null should be no association. The alternate is association. So I will fix that. All right. We're going to edit 43. The null and alternate are backwards. Okay. So what happens? We get a test statistic of 2.065. The p-value, 36%. You're in the body. F2R. F2R, there is a lack of evidence of association between gender and finger length. Okay? And then the last one says what I told you not to worry about, but we'll show you what a question will look like. Are these homogeneity or independence? You look at it this way. When you compartmentalize the data, when you divide this up, if you did it before you collected your data, it's homogeneity. If you did it after you collected your data, it's independence. So this says they selected a random sample of people before 1980 and a separate sample of people born after 1993. Homogeneity, 2 populations. Vegan and vegetarians, it was 1 population, and they categorize it after they collected the data. Okay? So pre and post stratification is what that's trying to communicate to you.